All right, let's begin our final unit. So, we have about 3 weeks left in the semester. We're going to cover 3 more chapters: static electricity, circuits, and magnetism. I really enjoyed this whole unit. Electricity and magnetism are fascinating. They're fun to talk about, and I think you guys will appreciate that we don't actually do a whole lot of math through this entire unit. Chapter 11, circuits, will involve a decent bit of math, but Chapter 10 and Chapter 12 are purely conceptual. We will look at a couple of equations today, but we're not actually going to apply them. We're not going to have to read problems, get numbers, and plug them in, and so on and so forth. We're just going to mostly talk about electricity. So let's get to it. So, Chapter 10, static electricity. Everyone has felt a zap of static electricity. I'm sure you've gone down a slide, shuffled through a room with some carpet, and then you go to touch something metal like a doorknob or your car, and zap, it hits you. And the question is, where does it come from? Well, you're certainly not alone. Almost everyone has felt a zap of static electricity, and not just everyone now, everyone throughout the history of time. Anyone who experienced some materials rubbing together might have accidentally picked up a little static electricity and felt this discharge. And while this may seem commonplace to us, this might have seemed magical to people hundreds of years ago. And it certainly was fascinating. And the first studies actually came from the 16th century. It was documented that scientists in Europe studied charge, but said they would create it. We know they're not really creating it. They were sort of just moving it around, and then they would store it. They would get electrons onto some sort of rod. They would then place that, make contact with some sort of metal ball, and they could store the charge and then do simple experiments to try to learn more about electricity. What was this magical stuff that allowed lightning bolts to come out of your fingers? And they found some basic things. They found that certain charges were attracted to each other while certain charges were repelled. And this led to the concept of opposite charges, positive and negative, which was actually a term coined by Ben Franklin. He was one of the big names early on in studying electricity, and he named the charges positive and negative. And unfortunately, he guessed wrongly that positive flows to negative. We'll talk more in the next chapter about the flow of charge, or what we call current. But it turns out that electrons are what flow, the negative charge carriers. We don't actually have positive charge flowing. He also did tons of other things. Amongst them, he listed things as more positive or negative, or really their tendency to become positive or to become negative. And this is called the triboelectric series. And it essentially tells you, if you take two objects and rub them together, which one will become positive and which one will become negative. This is something that we would have looked at fairly in depth in lab. You'll still get a little taste for it in lab that you do on your own, but of course it's not going to be the full treatment. Anyway, that's a brief history of static electricity. Let's take a step back, though, and talk about the nature of matter before we get into really where static electricity comes from. So we talked last chapter about the nature of matter, about solids and liquids and gases. And something that we didn't really dwell on was that everything is made of atoms. Solids, liquids, gases, they're all made of atoms. And atoms themselves are made of subatomic particles, even smaller than an atom. That's what subatomic means. And you might be familiar with these. Subatomic particles are protons, neutrons, and electrons. And each of them have types of charge. Protons have positive charge, neutrons have no charge or are neutral, and electrons have a negative charge. Now, in the atom itself, the protons and neutrons are the heavier subatomic particles, and they form the nucleus, while the lighter electrons orbit around the nucleus, kind of like the way that planets orbit the sun or the moon orbits the Earth. Except it turns out it's a little more complicated than that and needs, quantum physics to truly describe it. But a good basic picture in your head is to have protons and neutrons in the center of an atom in the nucleus, while those electrons orbit around the outside. Now, most atoms have the same number of protons and electrons. If you have the same number of positives and negatives, you end up with 0. Their net charge is neutral. Here I've drawn hydrogen, 1 proton, 1 electron, and helium. Helium has 2 protons, 2 electrons. But in both cases, we have the same number of protons as electrons. So the atom itself has a neutral charge. Well, you may be asking then, where does static electricity come from? Well, static electricity comes from an imbalance in the number of protons and electrons. If you have more of one than the other, then you do have net charge. You have leftover charge of one type or another. Well, how do you make that happen? It's by moving electrons. As you can see, the electrons are on the outside of the atoms. They're easier to move, to be given or taken away. The protons, those don't really move. It is possible to add or subtract protons to something, but that is what we call nuclear fusion or nuclear fission. It's a lot harder to take things out of the nucleus. It is much, much easier to strip away electrons from the orbit around the nucleus. So anytime we're talking about charge or leftover charge, we're always going to be moving electrons. We don't move the protons. So if that's the case, how do you get charge? Well, electrons on the outside of atoms can be gained or lost. If you gain electrons, you're getting something negative, which means you end up with a negative charge. Alternatively, if you lose electrons, it's like subtracting a negative. You actually get a positive charge from losing electrons. Not from gaining protons, but from losing electrons. That is how you get a positive charge. It's all about moving the electrons. We don't typically move the protons. That's a whole nother process that is much more complicated. All right, well, if an atom has lost or gained some electrons and it has an imbalance, we call it an ion. Ion means it has some charge, either positive or negative, and there's fancy names for those, cations and anions, but that's beyond the scope of this class. We're not going to get too in-depth there. All right, well, that brings us to truly the real question of how. How do you create an imbalance? Well, obviously you gain or lose the electrons, but how does that happen? That's really where the details happen. And that's what we'll talk about in our next video. It turns out there are 2 ways you can do this, through conduction or induction. So we'll stop this video there and pick up with how to create an imbalance of charge.